What's going on, everybody? So today I'm going to be taking a look at this FiiO E10K. This is the second generation of their Olympus 2 DAC and headphone amplifier combo. So I've been using this for about a month with my Bang & Olufsen H6 headphones. Now, it's a really great DAC and headphone amplifier for the price, but there's one thing that I would caution you on before I get to this teardown. And it's that make sure that the headphones you're using have a high enough impedance to be able to actually use the thing. So this volume control, it has a high and low gain, and I've been using it on the low gain, but the Bang & Olufsen H6 are 32 ohm impedance, and I really can only turn the volume on the DAC up to level 1 or 2. Any louder than that and it gets super loud. And of course, I would like to use the source from my computer at the maximum volume for the best sound quality. So anyway, that's just a small mention. It's not a huge deal killer, but it's definitely something that you should know. But anyway, I'm going to be taking a look inside this DAC because I've actually been looking online. Some people can speculate what might be inside it, but no one really knows for sure. So I figured I would open it up and we could take a look at some of the goodies inside it and see if we could confirm or bust what is being said online. Olympus 2, as it says there, USB DAC headphone amp. Interestingly enough, FiiO is actually based in China, so they actually make Chinese products, and you can see there with the Chinese written on the side. But I must say, that being said, they're very good. The quality on this it's really good quality. It's all metal case. It's just sort of the extruded aluminum that you'd see there. Gold on the front and back, and there's really only one complaint I've got here, which I'll actually point out right now, is that the way the USB sits inside the case and the board, it doesn't seat all the way in there, so you can see that the USB sticks out. I feel like it's a little flimsy. I feel like if I'm careless enough, I could just break it off. So that's the only complaint I have construction and build wise. But that being said, let's get down to the teardown here. Okay, so the first thing I'm going to do here to start this off is actually pry this front knob off. I don't think the back will come off without this off. Yep, so that's off there. You see a little bit of adhesive tape on the front. That's probably not a bad touch. Okay, so now I'm going to unscrew these back screws. So these are the only 4 screws I see. Okay, so got those screws off. Let's pop this top cover off carefully and see what's in there. Looks like a little bit of, I don't know if you can see it there, a little bit of foam keeping the circuit board inside the case itself, which is kind of a nice touch. Keep it from clanging around. So let's really carefully, I'm pushing on the front here, I'm going to carefully grab this and just slide it out. Alright, well I got a little bit tighter zoom on this main board here. So this is going to be the top side that we're looking at. And it's actually pretty chock full of stuff. One thing that I noticed right away is there's tons of bulk decoupling. Man, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrolytics just on this top side. Now that's probably the only side we'll see them on because they're bigger and heavier. And so the flow soldering process will usually demand that all the heavy things are on one side. One thing that I can see right away is that this USB connector is pushed all the way up to the edge. It's flush with that edge there, and that's why you get the weird depth mismatch with the USB cable. They've got the room. I would have liked to see them just push that back there. Got our line out, our gain selector switch, coax out, our power LED, which is that nice blue, the bass boost switch, and the headphone jack out. So on this side, really the biggest component here is actually this potentiometer. So I wonder how many contacts there are. Now that's interesting. Let's see if we can get a look at that. They've actually got this pot to save vertical space. They've mounted it on its own little daughter board assembly, and then they've glued it down sideways. So because that side dimension is probably like 2 millimeters less than the vertical dimension, that's a cute little solution. I kind of like that. Let's take a look at the back and get to the real good stuff. Okay, so on the back of the board here is where we've got pretty much all of our surface mount logic. A couple things to notice right off the bat, some good, some bad. There's tons of solder residue on the back of this. I know it's a little bit nitpicky, but it's not that hard to wash off. I mean, it's already an automated process. This isn't the cheapest of cheap circuit boards, so I don't know why all that flux residue is there. One thing that is good to see here, we could see these spring-loaded push pins. These guys are in there so that when the front and back case are pressed against the actual board, it shields, it makes a conductive shield with the case, which is good. That's a good design attribute. I think that was a smart choice. It shows that these guys actually care about creating something quality. So you hopefully avoid any interference, EMI, ground loop, 60 hertz noise induced from other junk around your amplifier, stuff like that. So thought that was a good touch, good work. One other small thing here is this little piece of foam here, which actually shields the connector from shorting onto the grounded case. So once again, a good design touch. So now let's take a look at what all of the chips are. The first one here actually was a little bit obscure. It took me a bit to find it. This is a Tenor TE5022L, which is a 24-bit 96 kHz USB audio IC. So this actually directly communicates with the USB line and spits it out in some serial format, I would assume. I'm not actually sure because I couldn't read the datasheet because it's in Chinese. So I'll link it to you. If you want to take the time to translate it with Google Translate or whatever else, be my guest. Maybe you can fill me in on a little bit of info there. Next one is this guy. This is going to be our, it's just an EEPROM, I believe. FM24C08. That's a 8K 2-wire interface serial EEPROM. So pretty standard, just the configuration data for that USB chip. Next, we've got the real juicy bit. Okay, so this guy, we've got a Burr Brown PCM5102A, which is a 2-volt RMS stereo DAC with 32 bits and 384 kHz PCM interface. So this is really the bread and butter of this USB DAC. This guy does almost everything that you care about on this board. We've also got this tiny little MSOP 8. I have no idea what this is. I couldn't really find any meaningful data. I'd probably guess it's just an output buffer, but I don't know. Next, we've got this guy. This one also I could not find any data sheet on. I didn't spend too much time searching for it. So this is a TI part. It's listed as, or I guess the markings on the front are 01642A, and then next to the TI symbol there's a 53K there. So I don't know if you can see that, but if you know what this chip is, my guess is it's just a simple op amp given what is nearby it. And in fact, the one below it is going to be an LMH6643, which is just a high speed. It's like it's fairly high speed. I think like 100 megahertz rail-to-rail amplifier. So this is just going to drive probably the line out or the headphone out. So my guess is, given that it's just got tons of passives, my guess is the one above it is also an op amp. And then the last one is actually pretty interesting. This is going to be the LM2663M, which is actually a switched capacitor voltage converter. So this guy's a little charge pump controller. And my guess is that they're using this to generate the rail supplies for the op amp so that you get a higher supply than you can get with the 5 volts from the USB spec. So the dead giveaways, I mean, you've got the caps that you're driving here. So here's your input decoupling, probably the charge pump caps. And then we've got 2 really beefy coupled inductors here, which I'm guessing they're just using in series to actually achieve double the inductance from each inductor. But you can see all 4 of those pads are actually separately soldered, so they're not shorted there. So my guess is that they're doing a charge pump architecture. They've got an output cap, and then they're just filtering it inductively to keep that ripple out of your sound. The fact that they can use a cheap switch cap power supply is actually really impressive, because this guy, if anyone's listened to it, it has absolutely no hum. You can put it on, you can crank the volume up with nothing playing, and I actually can't discernibly hear the slightest buzz with my low impedance headphones even. So that's a pretty impressive fact. They really did a good job filtering that power supply, which is super impressive. So anyway, that's what we got on the back. There's not much else that's noteworthy. We can see the actual daughter board there for that pot that they have on their side. But other than that, I'm fairly impressed with the construction of this DAC. It's really a pretty impressive little deal, and the parts that you get on it, aside from this Chinese tenor something, I wish they would have used something brand name. I know TI makes a ton of chips that do exactly what this part is doing, but aside from that, I mean, the parts that you get on this, aside the circuit board, all of the construction, the outer case being metal, the price that you pay is probably less than you'd pay for the individual parts if you wanted to build this on your own. Let alone the fact that you would have a very hard time cramming all these in and doing layouts so that you would get clean output signals. This is a pretty decent layout. Someone obviously put some time into thinking about how they were going to do this layout. That's the way I'll put it. So it's definitely not a novice layout. All of the passives are really, really thoughtfully laid out. If I had to guess, I'd say it's probably a 2-layer board. So the fact that all of this is laid out on a 2-layer board, and there's quite a lot of big pieces there, and a lot of just large size switches and packages. So I'll link to a couple of technical reviews. There are a couple people online who have actually theorized on what's inside of these DAC boxes. So I'll link reference to those, link reference to the data sheets. Yeah, if you have any questions, or there's anything you're wondering about, or any comments, or if you know what a couple of these mystery chips are here, do let me know. I'll be sure to give you some credit there in the comments. But yeah, I'd say I'd give this a 7 out of 10 on build quality. Take out all of this solder residue, that USB, the mismatched USB plug depth, and yeah, sound quality definitely worth the buy. So there you have it.